Okay guys, so once you get the clearance measured on your main bores, we can go ahead and... Alright, now once you get your crankshaft installed, when it comes to blueprinting, there's several other critical checks that you have to make, and one of them has to do with our rings. These are our piston rings here. They have these are a moly coated top ring, and of course this is our oil ring here and our second ring here. End gap is one of the most important things that you will check. Now, as a general rule, you want about 3.5 to 4 thousandths. I like to stretch that out to 4 thousandths per inch of bore. Okay, so we have to measure this gap at the end of the ring. The gap at the end of the ring is critical, because if the gap is too tight, what happens is the gap is there for heat expansion. If the gap is too tight, then the ends of that ring are going to butt up against each other, and it puts pressure on the ring lands, and it will just literally blow a big chunk of aluminum out of your piston and blow your engine. That's why you never want to put a turbo or a lot of nitrous on a stock engine without gap in the rings, because you end up blowing your engine. So that ring end gap, in some cases we have to file that gap. I've done some videos and some builds where we actually filed the gap. So in this situation, we're not running any boost or anything on this motor, but we do want to make sure that our gap is correct. So I'm going to show you how to gap the rings, and this is actually part of blueprinting. Now here's the thing. So say this is your number one piston here. The rings that are going to go on this piston need to be checked in the cylinder that this piston is going to go into, right? So we're going to number as we do this, we're going to check every single gap on every cylinder. I'm not going to do that. I'm not going to check all 8 cylinders on camera. I'll do one for demo purposes, but just make sure that your whatever cylinder you're gapping that ring in or checking the gap on, that it actually goes in that cylinder on that piston. That's really important, because the cylinders can vary slightly in size from cylinder to cylinder, not too much, but I mean, you know, there's slight variation, so you just want to make sure that your gap is right on every single one. Okay, so the first step is to get the ring into the cylinder bore. All right, so this is our top ring here, and we're gonna put it into that cylinder. Now, when it comes to the gap, one of the really important things to remember is that ring has to be perfectly square. It can't be, so getting that square by eyeballing it is very difficult. So what I do is I take the piston and I put the oil ring on it. So now when I put that into the bore, it's only gonna go down until I hit that oil ring, and it's gonna catch the bore, and this flat top piston is gonna square that up. So we're just gonna take our piston and we're just gonna push that ring down until we catch the bore with our oil ring. Okay, so we caught the bore there. Now it's flush. Now I know that I have squared up that ring. Now to calculate the end gap, we got to do a little bit of math. A lot of you told your teacher in school, I don't need math. Why am I going to need geometry and trigonometry? Well, if you're going to build engines and machine engines, you're going to need both. So, all right, so we're going to look at our calculator here. So our bore size on our engine is 3.900. That's the LS bore size. So we got 3.900, and we want about 3.5 to 4 thousandths per inch of bore. I'm going to say 4 thousandths per inch. So 3.900 times 0.004 is 15 thousandths, or 16. We're going to say 16 minimum. Honestly, guys, we need to see more like 18. We like a couple extra thousandths in here on motors that we're going to run hard. If you're going to run boost, then you're going to have to file them even bigger than that. And most ring manufacturers have a chart that tells you how much ring gap you need for X amount of boost or nitrous. So we're going to start with 16 here. 16 is our absolute minimum. All right, so here's 16 thousandths. So you can see the gap right there. Maybe I'll zoom in on that a little more. You can see the gap there, and this is our 16. So we're just going to very carefully make sure that that goes in. So that is 16 thousandths. and it is going into that gap no problem. So we're happy with that. But we want to know exactly what that is. So we're going to keep going until we get one that doesn't fit. My philosophy is a little extra clearance is infinitely better than not enough. When things are on the tight side, as far as clearance goes, I get really nervous. If they're a little bit on the loose side, I have no problem with it. A couple thousandths ain't gonna kill it. So there's 18, so 18 is going. So we've got already a couple extra thousandths of clearance, which is good. That makes me happy because especially in the state that I live in, when it's 115 degrees outside, a little extra clearance is a little extra insurance, and it's not gonna affect the performance at all of the engine. Now we don't want that gap to be huge. All right, so there is 19, and it's going, but it's a little tight. So let's put 20 in there and see what we come up with. So this is 20 thousandths here. Yeah, that's not going. I can't get 20 to go in, which is good. So 19 went, 20 is not. So we got about 19 thousandths of end gap there, which is fantastic for this engine. It's a few thousandths bigger, but keep in mind, a human hair is 4 thousandths thick. So our minimum is 16. This is 19. So that is the amount between what we're reading and what our actual minimum is less than the thickness of a human hair. When you got a bore this big, that doesn't make a dang bit of difference. But that extra clearance does make a difference when you're talking about heat expansion on these pistons. So we're happy with that. Now remember, you got to check every one. You got to check them all. You also got to put your second ring in there and square it up and check that as well. We're going to square that up with the piston. And that gap looks very similar on this one to the last one. So I'm just going to take the 21 like we did. Let's see if that goes. And it doesn't. 21's not going. So we got about, let's try the 20. Nope, it's tight. Go down to 19. See what we got here. Oh yeah, the 19 falls in. Okay, so both of these are reading, the 20 actually went in about halfway. So this is actually slightly bigger than the top. They're pretty close to being the same. So I'm happy with that. Now, keep in mind, like I said, these two rings, I'm gonna put them now with the piston that's gonna go in this cylinder, and I'm gonna label that, right? So make sure that you do that. So the next thing we wanna look at here is our bearing clearances on the rods. We already checked all the mains and got the crankshaft installed. Now, the connecting rod bolts do have a torque angle requirement for torquing. We've done a little bit of investigation on these powdered metal rods as far as bearing crush goes, and what we've discovered is you don't really need to do the torque angle to get the clearance on it. If you torque these bolts to about 38 foot-pounds, so what we did is we torqued them with the torque angle, checked the clearance, and then we torqued them to 35 to 38 foot-pounds, and we checked the clearance again, and it's the same exact clearance. So once we do the final installation and we put these in, we are going to do the torque angle on them because that's what GM requires, and we want to make sure that these are right on the money. But if you go ahead and torque this to about 38 foot-pounds, you can check your clearance here and it's going to be accurate. So what we did is we installed our rod bearing in there. Now the nice thing is the LS rod bearings are the same rod bearings as the early small block Chevy. It's a 660, it's a 663P if you're using Clevite bearings. The rod journal size is the same as the early small block. It's 2-inch 100 thousandths. So 2-inch 100 thousandths is what the journal size is, and we need to compare that to our bore size here. Okay guys, so now we've got our mic set for our crankshaft diameter size. The rod journal is 2 inches 100 thousandths. That's what this is set for. We got it locked. Then we're going to take our dial bore gauge here, and we're just going to put the fingers in between like we did before, and then we're going to zero that indicator out. So let's see where we're at. I am right on 0 there. Okay. So we know that 0 on our dial indicator represents our crankshaft journal diameter. So we torqued our rod to get the correct crush in here. And then we're just going to go ahead and put our dial indicator very carefully in here, and we're going to check the inside diameter of this. And I have 2/1000. Okay, so my 0 on here is the crank size, and if I go to the smallest point here, my dial's reading 2/1000. So that tells me that I have 2/1000 clearance between the connecting rod journal and the connecting rod bore, which is in spec. So if you look up your specs, they give you a really wide spec on this motor for the rods. It's 0.0006, which is just a little more than a half a thousandths, and the service limit is 0.003. So that's like a 2.5 thousandths spread, which is significant. But 3 is a maximum, and we're at 2 thousandths, so we're right on the money with these. And again, I'm going to check every one. You got to mic each journal. Okay, so you got to take your micrometer, because crankshafts, I mean, the journal sizes may vary. You may have a little wear if you're using a standard crank like we're doing. We didn't really have any, but you never know. So you got to mic each rod journal, calibrate your dial bore gauge, and check that rod that's going to go on that journal with the bearings torqued in here. You got to check every one of them to make sure they're right. You know, you really can't skip anything here. Some guys will measure 1 or 2 of these and put them together. That's risky, right? It's better to take your time and make sure that you measure everything. That way, and one nice thing is when you check every single clearance on every single cylinder and rod and journal, once that thing goes together, it gives you a lot more confidence. When it's, you know you didn't really skip anything, you didn't overlook anything. And really with an engine, you really can't overlook anything. You know, you got to make sure you cover all your bases here. So take your time and make sure that you check every single one of them. I'm going to do that off camera because if I do it on camera, it's going to be like the most boring video ever in the history of the world. You guys will want to like leave. So we'll get those checked and then I'll come back. Another one, while we got these here, we might as well talk about this too, is your cylinder to piston clearance. Now, the cylinder to piston clearance is the clearance between the skirt of the piston and the sides of your bore. Now, where you mic the piston is critical. The piston manufacturer will tell you how far down from the top to mic this, because the skirt actually is slightly tapered, and if you measure it down at the bottom or too high, you're going to get a false reading. One of the nice things about Sealed Power is they have this little blank spot right here, and they've put that there in order for you to measure this. So the coating on these skirts, according to Sealed Power, does affect the clearance slightly. They want you to take into account the thickness of this coating here. What I've discovered is on an engine like this where the cylinders are standard and we actually power hone the cylinders, when we power hone these cylinders, we take a little bit of material out, and these cylinders are actually about a half a thousandth larger than they were standard, which is still completely in spec, but like I said, there's a little extra clearance there, and with these Sealed Power pistons, we've found that the clearance comes out really good even with the coating on them. So let me show you how we check that, and we want to cover that base and make sure we do it. So first of all, we need to mic our piston. Again, your piston needs to be mic'd. Don't mic it up here on top. This is way smaller than the bore up here. You want to mic it on the skirt, and we want to put the fingers of our mic right on that spot right there where they have designated. So we're going to take our 3 to 4 mic, since this is a 3-inch 900 bore. I'm using a 3 to 4. This measures from 3 inches to 4 inches. I'm just going to go ahead and very carefully, be careful with this. You don't want to damage the piston. And make sure that the fingers of the mic are on that spot, that designated spot there. And we're just going to go in and very gently kind of center it up there, and we're going to mic our piston. Make sure that we have a little bit of tension here. So that is our piston size right there. Now we're going to lock it, And I am measuring 3-inch 897. So I'm measuring 3/1000ths smaller than our bore size, or so we think. So now that we've got our piston measured, let's go ahead and set this up, and I want to put this in the bore and we want to see the difference. Okay, so we've set up our dial bore gauge with the correct mandrel in it, and we've got our mic locked at the piston size. We mic'd our piston that's actually going to go in this bore, and then we're just going to do the same thing. We're going to take this, we're going to put these between the fingers of the mic, and we're going to zero out our indicator. We're going to zero out our indicator. Okay, so my indicator's reading exactly 0 here when I put these between the fingers of the mic, right? If you look at that, let's get this in there. It's kind of tricky. So we're reading right on 0. Now what I've done here, as most of you have already figured out, is I mic'd the piston and I duplicated the size of the piston right here with this on 0. Now, let's go over to the block and we'll be able to see our clearance, because when we put this in, we're going to see the difference between the piston and the bore. We want to see this difference. So there we go, we're in the bore. Right about 3/1000ths clearance, which is perfect for this piston, right on the money, okay? So, and again, we're going to mic each piston. The pistons are pretty much going to be the same size, but if you see that, there's the next cylinder, 3/1000ths clearance. Let's push these rings down. Again, about 3/1000ths clearance right there, which is exactly what we want. So, and again, we're going to check them all and make sure that we don't have, now we've already checked these cylinders, we've checked the top and the bottom of the cylinder, and we've checked out around. They're all round and untapered. And so that's basically what you do. You want to make sure that you have the correct amount of clearance in here. 2.5 to 3/1000ths is really good for these pistons. In the old days, when you had forged pistons especially, man, you had to run like 7 or 8/1000ths clearance, and you had piston slap and all kinds of stuff going on. I did an engine not too long ago. In fact, it was an LS, it was a 6.0, and we used Mahl forged pistons in it, and the clearances are ridiculously tight. I think it was like 3/1000ths, 2.5, 3/1000ths, might have been 3.5, but it was somewhere in there. And you know, I actually was like, because I'm kind of old school, I was like, man, that seems like really tight clearance for a forged piston. And I called Mahl Pistons up and I said, man, are you sure? It's 2.5 to 3/1000ths or whatever it was? And they're like, yeah. And I talked to the guy, had a little conversation with him, and he said that with the piston technology and the manufacturing technology and the metallurgy that we have today, they've gotten the forged pistons down to the point where they can run them tight now without any, you know, they've got that expansion rate under control. In the old days, the forged pistons, man, the metallurgy wasn't there, the manufacturing technology wasn't as good, and we had to run gobs of clearance, and they were all noisy when they were cold. Those days are pretty much gone. Even forged pistons nowadays you can run them really tight, and you don't have any problems with them. So, but stick with what the manufacturer says. That's the main thing. The manufacturer says on these pistons 2.5 to 3/1000ths is what they want, and we're right there, 3/1000ths. So we're happy with that. But again, make sure you check everything. You got to check this and make sure that it's 100% right. Okay, guys. Now, so the next step is to get the crank in. Now, normally I would put the camshaft in first because it's easier to get to, but unfortunately we haven't really decided what cam. I'm having a hard time getting the customer to make a decision on that, and we'll figure it out. We're close, but we're going to go ahead and lay the crank in the engine. And normally I will use engine oil on here, but if you have an engine that you think might sit for a while before it's installed, then I would recommend putting some heavier assembly lube on here. Don't touch the bearings with your bare finger, but we've got assembly lube on there, so you can go ahead and spread it around. And then we're just going to lay our crank gently in. We've already mic'd the crank and checked all the clearances. Everything is right on the money. Now on your crankshaft, the one thing that I would advise you to do on these cranks, you need to be really careful with that reluctor gear that's on the back. Just go straight in. Our thrust bearings in the middle. You want to be really careful with this pickup gear. This is pressed onto the crank. If this thing gets bent or damaged, you basically have to replace the crankshaft. It is pressed on at the factory with a special process, and I don't know of anybody in the aftermarket that's been able to press those on. Maybe somebody has been, but I know that those things can cause a lot of trouble. If this wheel gets bent and has a run out, you're in trouble. And it's easy to bend if you bang it or damage it. So you really got to be careful with that reluctor wheel. And that's the pickup for the ignition system, so it's important. All right, so once you get to that point, and we're just going to oil up the journals, this thing should turn with no problem. And of course, we haven't got the crush on the bearing yet, but we're going to go ahead and put a little lube on the top of these, and then we'll put our main caps on. So you want to just take and line your bolt holes up. And like I said before, it's okay to go ahead and tap that cap down. It actually needs to be flush with the block. And of course, you can use your bolts as guides. And then we have these side bolts. You don't want to torque these up until you get the side bolts in. And I actually, before I continue this, have to go to the Chevy dealership and get a set of those bolts. You could reuse the old ones and reseal them, but again, GM says to replace them, so I'm going to replace them. I'm going to put brand new ones in. I'm going to just go spend the 35 bucks for new bolts, because I want to do everything according to what the manufacturers and the engineers who designed this thing say. So I don't want to have any problems.